Hello, students, friends, colleagues, C# learners, YouTube world. This is Dr. Satish Singhal, PhD. I'll soon be a professor at computer science at El Camino College in California. In this video, I'm going to talk about selection control structure or if and else in C#. And really speaking of other languages, structure is similar in Java, C++, and JavaScript, and C language also. But today we'll just focus on C#. Okay. So basically, before we even do that, we need to talk about four kind of expressions that are there in computer programs. One is called arithmetical expressions, and they always have some sort of numerical value as the end product. Expression, by expression, I do not mean that you have to do some sort of arithmetic on them beforehand. They could even be single variable, so just think about that too. Or arithmetical operators acting on the operands. The second type is the string or text expressions. Expression is a text that is composed of strings and characters, and product is a string or text with 0 or more characters. The string expressions could have 0 character also. That is called a zero-length string. Then we have Boolean expressions, which can only have two values, true or false. And Boolean expressions are therefore binary in nature. There are other forms that mimic Boolean true and false. A non-zero value is considered true, and a zero value is considered false. In circuit diagrams, on switch is considered true, off switch is considered false. Okay. Expression can also be software objects, but we won't talk about them today. Okay. Here's the example of arithmetical expressions. We define int score as 1 equal to 90. Then score 1 is an arithmetical expression with value 90. If I define score 2 equal to 85 int type, then score 2 is also an arithmetical expression. And on each time we are showing the map of the RAM in the program up to that point. So map in the RAM when score 1 is declared is like this. Map in the RAM when score 2 is declared is like this. Then I declare int total score equal to score 1 and score 2. So total score is also an expression. Sum of these two is also an expression. This is also an expression. Okay. Map in the RAM looks like that. All three score 1, score 2, total score are left hand side of arithmetical expressions, and they exist in the RAM. And we can call this also as an expression. Okay. Now we show an example of string expression. So here it's available in C and C++, C++ and C#. And each time again we are showing the RAM map. If I say string first equal to John, then memory location first include John. So first is a string type expression. If I say string space equal to 1 space stored in RAM like this, then space is also a string expression. If I say string last equal to do stored in the RAM like this one, well, the last is also an expression. Okay. Then I say name equal to first plus space plus last. In the RAM it is stored like this one. But name is an expression, and three of them together is also an expression. So these are examples of string expressions. We want to talk more about strings and characters. String and characters can be added to form a composite string. Character is a single character on keyboard. A string can have 0 or more characters. Pair of double quotes with no space between them is a zero length string. For example, this is a zero length string. Characters are like character A enclosed in a single pair of apostrophe 9 in a single pair of apostrophe, %sign inside a single pair of apostrophe. Strings take up more storage in RAM than characters. Characters in C# are just 2 bytes, and I will have to say string is probably at least 32 bytes or more. Understand that this is a string, but this is a character. This takes 2 bytes. This takes at least 32 bytes. Some languages and programming environment use pair of single quotes to represent a string. In some languages, strings are represented like this. For example, Oracle database is like that. Okay. Then finally, we talk about Boolean expressions. It's the same data type in C++ and C#. In C#, Boolean data type is called bool. Be careful, all languages may not have Boolean data type. All cases, declarations, RAM map is shown simultaneously. If we declare double temperature equal to 100.5, RAM map is this. And then, since this is a temperature more than 98.4, I can set bool has fever equal to true. In this case, has fever is a Boolean expression, and in the RAM it looks like this. If I define a variable called earnings, which is $2 million, so earning variable will look like this. But Boolean variable poor is poor if earning is that much is being set to false. So Boolean expression set to false, and in the RAM it looks like this. Okay, so these are the examples of Boolean. This is an example of Boolean expression. That's not an example of Boolean expression. This is an example of Boolean expression. Okay. Okay. In C#, read that as C#, not C. These are the control structures. Sequential structures where program is executed in sequence, first line, second line, third line, fourth line, fifth line. There is no jumping from previous to later to previous lines, or from this line to that line or something. That's a sequential structure. Then we have selection structures that select certain alternatives, and in that we have if statement only, if and else. This includes nested if and else also. Switch, ternary selection statement, and then repetition structures. Those could be while, do while, or for. And for has 2 types, count control and iteration through some sort of array or collection. There is a go-to statement in C#. We will not worry about that right now. We'll worry about that in future sometime. So in this lecture and a few more lectures, we'll really just focus on if and else and nested if and else. Okay. Selection control structure based on if is like this, that we make some sort of assertion in terms of an expression, Boolean expression. If assertion is true, then we do a task, but if it's not true, then we skip this entire branch and do statements which are after that. So basically we do statements sequentially up to here. Here assertion is being made. If assertion is true, then we do this task as well and move sequentially down for other program statement like this. But if this is false, then we skip this all as if this didn't even exist, and we just do normal sequence from then on. Yeah, that's an example of if structure. Assertions are Boolean expressions. These are the examples of assertions. We assert that we are eating broccoli tonight. If we eat broccoli, then assertion is true, else assertion is false. Now, that was the wordy description of assertions, but generally assertions will be made in terms of expressions that are formed by relational operators. So we talk about comparison of relational operators. Assertion based on same values of variables which are same type in data type can be made by comparing them using comparison or relational operators. Thus, when two data of same type are compared, then the result of comparison may lead to a true or false decision. Comparison operators are binary in nature because they take two operands, one on left, one on right. So what are the comparison operators? There are 6 of them, and one has to be very careful with these. Okay, so strike out this one, that's JavaScript, and strike out that one also, that's JavaScript. I'll talk about this in a minute. Greater than, and it is formulated like this: A1 and B1 are the same data type. This could be int, they could be character, and C# they could be strings too, although meaning of that would be a little hard to understand. You'll have to do more work. So assertion being made here is A1 is greater than B1. So if A1 and B1 are integers, if actually A1 says 10, B1 is 5, then assertion is true. So this expression will result into true in that case. Otherwise, assertion will be false. Then you have less than operator. So if A1 is actually less than B1, then assertion is true. Otherwise, it's false. And same way, I have greater than or equal symbol, less than or equal symbol, and not equal symbol. Understand that and we'll talk about that in a minute anyway. But when we look at test for equality or same content, then we do not use single equal. We use two equals, double equal, equal equal. So assertion being made here is that A1 and B1 are having same content. If that's true, then this is a true Boolean expression, otherwise false. Okay. There are some heartaches there's a gotcha in double. People forget what that means. So we're going to talk about that a little bit more in a minute. So use of comparison operator that have two characters in them requires that no space is left between the characters. Table gives the correct and incorrect forms. So this is the incorrect form of equal, this is the correct form, incorrect form of greater than or equal, correct form, incorrect form of less than or equal, correct form, incorrect form of not equal, correct form. And this is JavaScript, so we're not going to worry about that. Okay. In most languages, 6 comparison operators are applicable to numeric string and character types, and floating point also, but there are some problems with that. Comparison operators are also called relational operator. Comparison operator, interestingly enough, are not applicable to Boolean data type. Never try to do that. Think of true and false, which are Boolean type, as quantum states. Quantum states are not comparable the way numbers are. They are discrete states, and that's all there is. One is not greater than or less than or equal to the other. So just remember that part. One common error that is made is, let me get all this stuff here first. In C#, one equal sign is an assignment operator. And this should not be confused with comparison operator equal equal, because the equal equal comparison operator simply compares the content of two operands and does not alter either. When you use equal, left hand side is altered to become same content as right hand side. Let's take example. Let's say we say var x equal to 5, var y equal to 6. Then we say x equal to y. This means you store into x the value 6. Okay? And this means you store into x what is stored in y. X can be altered in this case. Okay? So in this, equal alters the left hand side. But if we do this, var r equal, and then say r equals x equals y. So in previous assignment, x became equal to y. In that case, r equal stores true. But notice in this operation here, x and y are not, x is not altered. Okay? It does not alter x. So this is very important fact to remember, that when you use equal equal, you have read-only access to its operands. When you use equal, you have write access to the left hand side. And this is what we say here, that another way to look at the same issue is, remember that 6 comparison operators we studied have read-only access to their operands. They never alter the value stored in the operands. On the other hand, the assignment operator equal has the right access into its left-hand operand. So if we do x equals y, we do have right access to memory location x. If value of x is different than value stored in y, then x is altered to make it to be sure as same as value stored in y. So understand this difference, that comparison relational operator only have read-only access, but assignment operator has write access to the y, second left-hand operand. One more time. In execution of this statement, like this one here, this one, no write access is allowed into x and y. There is read-only access into x and y, thus content of x and y do not change. And r equal must be Boolean type. True will be stored in this if x and y have the identical content. False will be stored if x and y have different content. So this is very important to understand. What does applying comparison operator means? Means that we are making an assertion. Based on value of data being compared, the program will know whether assertion is true or false. For example, if you write something like this, var age student equal to 25, var age professor equal to 45, var is student younger equals age student less than age professor. So look at this code here. Tell me what is being stored inside this variable here. Think about it. Pause the video if you have to, if you need more time. What is being stored here? Answer this question. Write down answer on a piece of paper. I will proceed with the answer only after that. Done? Okay. So if you answered true, you will be correct, because we are really doing this 25 less than 45. So 25 is indeed less than 45, so a true will be stored. And we are doing the same thing here. Expression age student less than age professor, making an assertion that variable age student is lower in value than variable age professor. Since age student is 25, age professor is 45, the assertion is true. Thus value stored in is student younger is true value. So in computer programs, we make an assertion. If assertion is true, then a Boolean value true is used. Otherwise, a alternate Boolean value false is used. Here's a pictorial way of making the assertion. Assertion we are making is, we are eating spinach tonight. If that's true, we'll cook spinach and eat. If this is false, we'll do nothing. False branch does not need to do anything, or could cook something else in the end. So this is the flowchart analogy for the assertion, or the if and else statement. Okay. Here's another example. Read student score. Assertion we are making the score is greater than 60. If that is true, we print passed. If that is false, we print failed. That's the another example of the assertion or if and else statement. In programming language, the diamond shape is replaced by a structure called if then else. We declare var score is 80. If the score is greater than 60, console, this is console, misspell, SOLE, dot write line print passed, otherwise console dot write line failed, SOLE. So in this case, since the score is 80, 80 greater than 60 is true, so program will print passed. But if this was by any chance less than 60, this will be false, will write failed. Okay. So out of the two, only one is done if then else. When we code if and else structure, the word then is not used in C#. And when we apply if then else structure, else block is optional. And we will not show Visual Basic code because this is C# class, so not shown. Okay, what I'm going to do, I'm going to skip some of the slide and come back to this a little bit later, but I'm going to show you, I'm going to come back in the next video and show you the operators. Relational operator I already showed you. There's another set of operators called logical operators. So I don't want each video to become very big in length. So I'm going to show you in the next slide, which will be logical operators in C#. And then we'll discuss some if coding, if and else coding, and if nested if and else coding. Okay? Thank you.